Section 5.2. All of Chapter 5 is extremely important because parabolas and quadratics, they are used all the time. From now until you stop doing math, you're going to use a lot of quadratics. So they're going to go over some techniques to deal with those. We want to be able to find the vertex of a quadratic, and we want to be able to sketch the graph. Now, to do a quick review of this, when we do a line, and what I'm going to do right now for fun is I'm going to say y minus k equals m x minus h. And what I'm showing you here is the equation of a line that's put in the same type of form as vertex form. This is point slope form from our line work that we did before. This is point slope, this is our slope, and then hk is a point on that line. And we call this point slope form when we're talking about lines. We do something very similar with quadratics, and we call it vertex form. And a quadratic in vertex form looks like this. The key with a quadratic function, so when we're talking about functions, the x is going to be squared. The key with a quadratic function is that one of the variables is squared, the other variable is not. hk here represents our vertex. Now notice that these negative signs must be here. Okay, so if we had y minus 3 equals a, x plus 2 squared, the formula requires a negative sign. So it would really look like x minus a negative 2 squared. And our vertex in this situation would then be negative 2, 3. Because this negative must be here. So don't just pull out whatever number's back there. The other thing to remember is that a line is determined by 2 points. Any line in math, geometry, can be determined if you have 2 points on that line. It will lock it in place. And when I require you to graph a line, I'm expecting you to have 2 points on the graph labeled. With a parabola, the expectation is that I want the vertex. That's a must. I must have the vertex. And then I want, I prefer 5 points total. I prefer 2 sets of symmetrical points. And we'll go over what that means. Some of the homework assignments just want 1 set of symmetrical points. So read the directions. If the directions say graph it, or if I give you a problem on a test, say, and I say graph it, I'm expecting 2 sets of symmetrical points. The book sometimes is only suggesting 1, but I think that you get a better grasp of what's going on if you do 2 sets of symmetrical points. It won't be difficult. So I'm expecting that you will have read through parts of 5.2, or you'll read through it while we're going over it. I just want to go over a few things that you need to know about parabolas. First of all, a parabola is a symmetrical graph. So if I just put a parabola on here, and I realize it's not going to be perfect, we would be able to, in this situation, if the vertex is at the origin, I would be able to fold this graph in half. There's an axis of symmetry on this graph where I could fold it in half. And that axis of symmetry on a parabola that goes up and down with the x being squared, where you have y equals some x squared. The axis of symmetry is always going to be an x equals something. In this situation, x would equal 0. This would be the axis of symmetry. This is another important piece of information that will be requested about a lot of the problems. So you need to make sure you understand what an axis of symmetry is. You're already familiar with squaring something. X times x equals x squared. If we had x plus 1 squared, that would be the same thing as x plus 1 times x plus 1, and we would just, go ahead and FOIL that out. The idea of squaring a binomial and reversing that process is very important to solving for parabolas. So we're going to go over completing the square, and let's just look at what the book has to say about this on page 177. you'll see they have a blue box there saying completing the square. If the coefficient of the quadratic term equals 1, then the number that completes the square is found by taking half of the linear coefficient b and squaring it, blah, blah, blah. Of course, this doesn't make any sense to you, but we're going to work it out. Okay, so what we have here is y equals x squared minus 6x plus 2. First thing we have to check, 1, we have to check the coefficient of x. Okay, here is the coefficient of x. There is no number there. That's a good sign. So whenever that's 1, we can go on to the next step. If it's not 1, we would have to divide that out. We'd have to factor that out. Oh, I have this wrong. First, before we even start this, let's make this number 2. Number 1, I want to kick out the constant. And that might sound funny. Kicking out the constant, this is a constant on this side, and I want to kick it out. I want to move it to the other side. So I'm going to get y minus 2 equals x squared minus 6x. Kick out the constant first. Second, I need to make sure the coefficient of x is 1. It is right now. 3, I take half of b and I square that. All right? So I'm going to take, this is b right here. I'm going to take half of that. And I always write it down this way because I think it's easier later on. So half of that is negative 3. Okay? Then I'm going to square that. And I'm going to add it to this side. Now, the thing to remember with this is that before this equation was balanced, this side of the scale equals this side of the scale. I just added 9 to this side, so I better be adding 9 to this side. If I don't, my scale will fall out of balance, and that will be a problem. So now what do I have? I have y plus 7 equals x, and if I were to take this, I could factor this down to x minus 3 squared. And the rule to know here is that whenever you complete the square, this number right here, this number that was half of b becomes the back end of this, which makes life easy. If you write it down, you already know it's going to be this way. So you take half of this. Make sure you take half. If it's negative 6, half of negative 6 is negative 3. Don't take half of 6 as 3. Take half of the whole signed number, and that becomes this back end part. Just like we have factored when we started, we reviewed that. This would be the same thing. If I asked you to factor this whole thing, you would end up with x minus 3 squared. So now what do we have? We have this in vertex form. Once you have it here, you have it in the y minus k equals a x minus h squared. In this situation, my vertex will be 3, negative 7 here. All right? That's what I have. Now, you need to know about vertex form. You need to know the formula. You need to know what the numbers mean inside, or the variables stand for in here. You need to know that x and y are your variables, that h and k represent your vertex. And we'll talk about a at length as we keep going. A mimics the idea when we have a line, we have y equals mx plus b. Slope, that whole idea, and here's the point slope form for this. For a line, a represents your slope. In a quadratic where it's squared, a represents, it's kind of like that, not exactly the same. A represents how narrow or fat the parabola is. And a also represents up or down. So to go over this quickly, if we have y equals negative 2x squared, okay, the negative means the parabola will be going down. The 2 means that the parabola will be skinny. If we have y equals 1/3 x, here my a is positive, which means it's going to point up, and 1/3 means it's going to be wider. So the larger the number, the skinnier the parabola. The smaller the number, when the number's a fraction, so between greater than 0, less than 1, it's going to be fat. And as the value gets larger, 2, 3, 4, it's going to get skinnier and skinnier. It's very much like the slope. A line that has a slope of 1 looks like this. As the slope gets bigger, it rises much quicker. The same thing with a parabola. When the A gets bigger, it rises much faster. When the A gets smaller, it fattens. So that's the important thing to know about A. Let's go ahead and work an example, number 1. Number 1, the example is y equals negative 3x squared minus 24x plus 11. Now in this situation, I'm going to take you through the steps as I would have them over here. First, I want to kick out the constant. Easy. Y minus 11 equals negative 3x squared minus 24x. Good. 2, check the coefficient of x. Here it is. My coefficient of x is negative 3. Blech. I can't leave it that way. I must pull that out. So I need to factor that out of here. So I get y minus 11 equals negative 3 x squared plus 8x. Now I can complete the square. I'm going to take 1/2 of b and I'm going to square it. So and I'm going to leave space on this side for whatever I get. And on that side. So half of this is a positive 4. 4 squared is 16. I added 16 to this side, or it appears that I added 16 to this side. So how much do I have to add to this side? Think about this and answer this question in your head. I did not actually add 16 to this side. I added 16 times negative 3 to this side. So because I added 16 times negative 3 to this side, I have to add 16 times negative 3 to this side. Well, 3 times 16 is 48, so this should be a negative 48. And that's the tricky part. That's what will get people. They will forget that if you have this A out here, and you add something here, that you have to then multiply it times A before you put it over here and add it to this side. So don't forget about that. It's very tricky. You might want to go over that a little bit in your head and think about that to make sure that that makes sense in your head. All right, so then we get y minus 59 equals negative 3 x. Now I told you before the little trick here, if we wanted to factor this down, we could go ahead and do the whole factoring thing. But if you write down half of b here, we know that that's going to be the case because we know we're completing the square. We know that half of b will end up being this number, and it's a positive 4. So here my vertex would be negative 4, 59. All right, and then generally speaking, what we like to do, they're probably going to ask you for a y-intercept. Now remember, on a y-intercept, x will be 0, because that's the, y-intercept x is 0. So I'm going to put a 0 in for my x. When I put a 0 in for my x up here, this is the easiest place to do it. I put a 0 in, I get 0 minus 0 plus 11. So my y-intercept is 11. Now, the other thing you're going to, a lot of times you're going to find a symmetrical point. And now look at the picture 5-2b, and you'll see them finding that symmetrical point. That symmetrical point, basically what they're saying is, at x equals negative 4 is the axis of symmetry. So we have 1, 2, 3, 4, there it is, okay. This is going to be terribly out of scale. So this is negative 4, and let's just say up here is 59. So here it is. And we know that 11, so that's 50, so this is somewhere around 30, so 11 is going to be somewhere like there. Well, if we have an axis of symmetry that we could fold down, which I told you before, the axis of symmetry when x is squared will be x equals negative 4. That is my axis of symmetry here. So if there's a point here, if this was a piece of paper and I did fold it over, this same point would be over here. Well, I already know what my y value is there. My y value is 11. I would just need to figure out what my x value is. Well, I started at negative 4. and I went to 0. Well, that was forward 4 units. If I go back 4 units, I will be the same distance. So negative 4 minus 4 would be negative 8. So this should be negative 8, 11. And that's just a symmetrical point, remembering that you can fold the piece of paper together. So this may be beneficial for you to watch this and then watch it again tomorrow, because this information is extremely important and you need to make sure that you understand parabolas very well. The homework assignment for 5.2 is listed on the Google Doc. Thanks.